In today's tutorial, we are going to be making a monster for our game. Now the monster that we're going to be creating is going to be a pathfinding monster similar to the one in Rainbow Friends, where there are several waypoints across the map that the monster will move around to, but if they see a player, they'll chase after the player. Now I've just got this little rig right here that I created just using a dummy that was in there, and I just changed a few of the colors and materials and everything and added a different face on there, and this is going to serve as my monster. If you would like to create your very own custom monster, you can feel free to do that by watching this tutorial right up here in the top right. But after you do that, you can come right back to this video because we're going to be making our monster. First things first, we need to go into our workspace right here, hover over it and click on the plus icon to the right of that and insert a folder. This folder we're going to rename to Waypoints, just like this, because it's going to hold all of our different waypoints for our monster. After that, we just need to put some parts around the map in whatever location you want to. I'm going to put one right here, and another one over here. You can have as many of these as you would like to, and they can be wherever around the map that you'd like. However, I'm just going to have 3 and put them semi-close to each other right now for the sake of this tutorial. You don't need to worry about naming them or changing the color or anything. We just need to put them inside of the waypoints folder, and that is done. We should also anchor them though, so that way they can't move around, and you can also turn off can't collide, so that way we can't actually collide with the parts. But after that, that's all we need to do for the waypoints. So now we can click on our rig, or your monster, whatever you want to call it, and let's open up this rig right here. Click on the plus icon to the right of this rig and insert a script. This script I'm going to rename to Pathfinding Script, simply because it's going to be our pathfinding script for our pathfinding monster. And I'm going to start off right here on the top by zooming in, and I'm going to create a comment with services right here just to keep our code nice and organized. Now we're going to need 2 different services. We're going to need the player's service, which is going to be equal to game:get service parentheses quotation marks players, and then the second service that we're going to need is called local pathfinding service, and this is going to be equal to game:get service parentheses quotation marks pathfinding service, just like this. Now the player's service, this is simply the player's service that you see right here in the Explorer, and it holds all the players in the game. Pathfinding service is a little different. You can't actually see it in the Explorer because it's something we call a scripting service rather than a built-in container service. Pathfinding service is what we're going to be using to actually create our paths that will go in between each of our waypoints, and we're going to use it for our rig here. After that, I'm going to create another comment for our variables. We're going to say local rig will be equal to script.parent, because we have our script inside of our rig right here. Now that is actually the only variable that we're going to need right now, but we may come back to it later. So let's go ahead and create another comment right here for our functions. Once again, just keeping everything organized. And we're going to say local function check for character. We just want to make sure that we check for a character and if that character is in the line of sight of the monster. And this is going to take character as a parameter because we're going to be passing the character to this function later on. Now, if you haven't already watched my raycasting tutorial, I'm going to try and explain this as best as I can, but if you really want a deeper understanding, feel free to go watch that other tutorial, which you can find in the top right here. But other than that, let's get right started here with a local variable. And this is going to be local ray origin, because we're going to start off with the origin or starting point of our ray. And this is going to be equal to rig, or our monster, find first child, quotation marks, humanoid root part, dot position. This is the position of our monster's humanoid root part, or their base part, and I guess root, which is the center of them basically. I'm going to say local ray direction. This is the direction in which the ray will be going, and this is going to be parentheses, equals to, parentheses, character dot humanoid root part. This is going to be our player's character dot position, minus our ray origin dot unit times 40. So we want to subtract these 2 different vector positions from each other to get the distance between them. And we use dot unit at the end here to get the direction that they're going to be going in, and we times that by 40 at the end here to get a general direction of where we want our ray direction to go. After that, we say local raycast result. And this is going to be equal to workspace:raycast. Inside of here, we need an origin, a direction, and something we call raycast params or raycast parameters. So this is going to take our ray origin, our ray direction, and then something we're going to say raycast params.new. Raycast parameters are a list of parameters that we have for our raycast, which are kind of like settings or options for it, but we don't actually need any of those, so we're just going to leave it blank. After that, we're going to check if raycast result, then, so if the raycast returns something, which means if it hit anything, then we're going to say local raycast instance is going to be equal to raycast results.instance. This is going to be the instance that the raycast hit. If raycast instance is descendant of parentheses, quotation marks, not quotation marks, sorry, character, then we're going to return true. Else, if there is no raycast result, then we're going to return false. Alrighty, so we have a simple function right here. Let's go ahead and explain what it does. I already explained to you these raycast result and everything, but if the raycast instance, which once again was the thing that the raycast hit, happens to be inside of our character, then we're going to return true, which means that later on in our function, we will be able to chase after that player. Otherwise, if the raycast did not hit anything, then we're going to return false, which means no, you cannot chase this player. After this, let's drop down a few lines and scroll down a little bit. We're going to say local function find nearest player with parentheses. Now we already have our player's service, but we need to make sure we get the players in that service. And since the player's service holds all the players, we can say local players with a lowercase p to indicate this isn't actually the service. And this is going to be players : get players. This is going to return a table with all the different players in the game inside of it, which isn't very necessary if we're doing single player, but we want to make sure that it is doable with multiplayer as well, just in case you guys are making a multiplayer horror game. Then we're going to say local nearest player will be equal to nil, because we haven't set a nearest player just yet. And then the local max distance is going to be equal to something like 50. Actually, let's just do 40 to make sure it matches up with our raycast direction up here. The max distance right here, this is going to be the maximum amount of distance that can be between our player and our monster. Next, we say for underscore comma player in pairs players do. We're going to loop through all the players in our game. We're going to say if player dot character does not equal to nil, so if the player's character actually exists, then we're going to say local target character is going to be equal to player dot character, and then local distance is going to be equal to parentheses rig dot humanoid root part dot position minus target character dot humanoid root part dot position dot magnitude on the outside of the parentheses here. What magnitude is going to do is going to return the length of these two vectors right here. When we subtract these two different positions right here, our rig's position and our character's position, it's going to leave us with the distance between those two. Let's say we had 5 minus 8, right? If you subtracted 5 from 8, you'll be left with 3 because that's the distance between those two. It's the same thing here. If we subtract the monster's position minus the character's position, we are left with the distance between those two. So that's how we're going to get the distance. Next, we're going to check if distance is less than our max distance and check for character with our target character. Then what this if statement is going to do is going to check if the distance actually is within our requirement for our max distance here, and we are able to see the character in the monster's eyes. Then what we're going to go ahead and do is we're going to check the nearest player, and this is going to be equal to the target character, and the max distance is going to be equal to the current distance, or our distance right here. Let's go down to the end of our for loop right here, and we're going to say return nearest player. After this, let's drop down a few lines and say local function attack parentheses, and this is going to be our character. We want to make sure we can attack the character. So inside of here, we're going to get our same distance variable, which we can actually just copy right from up here and just paste this right here. We will have to change the target character just to character though, but that's all right. Now we're going to check if distance is greater than 5. This is just the number that I'm going to use, but you can change this down or up if you'd like to. So if the distance is greater than 5, then we're going to tell our rig.humanoid to move to the current character.humanoid root part.position. This is just going to move to the player's character if the distance between them is currently greater than it is that we want them to be able to fight each other. Otherwise, if the distance is less than 5 or equal to it, then we can simply say character.humanoid.health will be equal to 0. And that's all that we need to do for now. So let's go down a few more lines here. Let's create a brand new function so we can calculate our path that we need to take to our different waypoints. This is going to take our destination as a parameter. So now when we create a path with Pathfinding Service, we need to specify something called the agent. And the agent is the current humanoid that we're using for our pathfinding. So in this case, it's the humanoid within our monsters rig. So we need to create a table for our agent parameters. So we're going to say local agent params, which is short for parameters, is going to be equal to a table. And we're going to press enter right here. We need to specify certain properties for our agent. Like for our agent height, this is going to be how tall our rig is. For me, my rig is about 5 or so studs tall. I'm just going to say 5.5 to be safe. It doesn't have to be completely precise, just as long as it's relatively accurate. After that, we're also going to want to say agent radius, which is once again the radius of our rig, pretty much the width. I'm going to put a comma after this, and then one more, agent can jump. And this is going to be a boolean, so this can either be true or false. I'm going to leave mine at false simply because I don't want my rig to be able to jump. However, if you do want your rig to be able to jump, then by all means you can do that and set that to true. That's all we need to do for our agent parameters, so we can drop down a few lines after that and say local path will be equal to pathfinding service, create path, and then this will take our agent parameters. What this line does is going to simply create a path using Pathfinding Service. It's pretty much setting up our agent with the agent parameters, but in order to finish setting up everything correctly, we need to say path : compute async parentheses. This is going to be rig.humanoid.position, comma, and then destination. This is going to do all the calculating right here. It's going to do all the computing, the calculating. It's going to take our rig's current position. It's going to take the destination that it needs to go. It's going to do all the math, and it's going to create our path basically. After that, we can simply say return path, and that's all that we need to do for this calculate path function. Now we've only got 2 more functions left, so let's continue going on. I know you love creating functions, so this shouldn't be a problem. We're going to say local function walk to destination, and let's put parentheses on the end of here, and this is going to take destination as a parameter. Let's press enter here, and we're going to get our path, which is going to be equal to calculate path with destination as the argument that we're going to be sending over. And then we can check if path.status will be equal to enum.pathstatus.success. Then what this is going to do is that our path right here, this is the path that we created right up here. Since we did return path, we can simply access that path by calling this function inside of this variable. And we're going to check if the path was set up correctly, then we can go ahead and continue on. So once again, if our path was successful, then we're going to say for underscore comma waypoint in pairs path : get waypoints parentheses. We're going to say local nearest player will be equal to find nearest player, and then if nearest player, then we're going to attack that nearest player and break. Else we're going to say rig.humanoid : move to parentheses waypoint.position, and then rig.humanoid.move to finished : wait. So sorry if I went a little fast there, but let me explain this. So our nearest player, once again, this is our find nearest player function up here. We used the same return nearest player as before with the path. So that means that we can get that nearest player simply by calling that function inside of this variable. Then we're going to check if the nearest player exists, then we're going to go ahead and attack that player. Now the attack function, it doesn't actually attack them immediately, but it checks if they can attack them. Once again, it'll check if the distance is greater than 5. If it is, then it will continue to chase after the player. Otherwise, it will kill that player. And we want to break the function after that because we don't want them to move to any other waypoints while they're chasing after the player. Otherwise, if there isn't a nearest player in sight, then it's going to simply move on to the next waypoint and wait until it is finished moving there. Now we can move to the end of our for loop right here, and we can say else. So if the status of the path was not successful, then we're going to say rig, not return, but rig dot humanoid colon move to destination minus parentheses rig dot humanoid root part dot position. Oops, sorry, not position. We need to do C frame instead. Dot look vector times 10. So what this is going to do is that if the path was not set up correctly, it's just going to move the character in a direction that is in front of them, just to keep the rig moving, so that way it doesn't look like the script was broken or anything. It's kind of like a failsafe. Now, last but not least, we need to create a last function that we'll just name patrol, and this is going to be the finishing up of our script. This function is going to tie everything up together, and we just need to say local waypoints, let me zoom in real quick, is going to be equal to workspace dot waypoints colon get children. Then we're going to say local random number is going to be equal to math dot random 1 and then hashtag waypoints, which will get the number of waypoints within that waypoints folder. And then we simply call our walk to destination function with our waypoints variable, square brackets, random number, which is going to get a random waypoint, and we say dot position. So that's all we need to do for this function. What this is doing is that this waypoints variable is going to get all the waypoints that are inside of our waypoints folder. This random number is going to return a random number between 1 and however many waypoints we have, which in this case is 3. And then we're going to call our walk to destination function with our waypoints, which is going to be all of these waypoints right here, with the specific number, which is going to be 1 to 3, and it's going to pick one of these, 1, 2, and 3, and it's going to send the position of that waypoint to the rig for it to move to. Now all we need to do is create a while loop, so while task.wait 0.3 do, we're going to say patrol, and that will just call that function. And this function will call the walk to destination function, which will call the calculate path function and the nearest player function and the attack function. So this will take care of all the other functions for us pretty much. Let's go ahead and click on run and you'll be able to see our rig move around. So it looks like I made a simple mistake right here. Position is not a valid member of humanoid workspace.rig.humanoid. It's on line 62. So let's click on this and see what we can do. First, we need to stop it and go back to our script. So it looks like when we did path compute async, we accidentally did rig.humanoid.position when I meant to do rig.humanoid root part.position. The humanoid doesn't actually have a position. It holds other properties. The humanoid root part is a part, so it can hold a vector3 direction and value and position. Let's go ahead and click on run this time, and now it should be working much better. And you can see right off the bat, our rig is on the move here. He's stopping at these different waypoints, going to a different one. Looks like this time he's going all the way over to that one. So yeah, he's going to choose different waypoints to go to, and he's going to be doing that indefinitely. Let's go ahead, click on stop, click on home, and then click on play instead of run, so we can see what this looks like with a player in here as well, instead of just him moving around. You'll see he's going to start chasing after us if we get too close. And we should be able to escape unless he's fast for us, which he does look to be a little fast. But yeah, just like that, we were able to escape, and he's going back to his path until he sees us again. And if we get too close to him, let's go ahead and test. Yep, we die. So that's a little unfortunate. And he's back to his path again. It looks like he saw us, so boom, we die. Oh, and we die again. So you may not want to put him too close to the spawn, otherwise you'll keep on dying like that. But that's how we have our little monster right here. But he looks a little goofy just walking around like that. So that's why we need to create an animation for him. Once again, if you have your rig rigged completely and properly, which you should know how to do if you followed that tutorial that I recommended earlier, then you should be good to go and click on the avatar tab and click on the animation editor. I'm going to close off the output for now and then click on our rig and name this animation to horror monster walking animation. Click on create, and then we can simply just go ahead and create a very simple walking animation. Now, I'm no professional animator, and I'm not going to put too much time into this, so don't laugh at me when it doesn't turn out all too great. Alrighty, so I've just got this little walking animation right here. It's nothing too fancy or anything, it's just his limbs moving back and forth, little torso rotation in there, and just some basic easing styles and everything like that. Pretty simple. Now, if you don't know how to animate, I've got a great tutorial up here in the top right, which you can watch, but it is pretty simple and you can get the hang of it pretty fast. After this, I'm going to click on the three dots over here and set the animation priority to core. After that, let's click on publish to Roblox. If you're working inside of a group, you need to set the creator from me to the group that you're working inside of. And if you're working inside of a friend's game, you need to make sure that they publish the animation, otherwise it's simply not going to load for any other player in the game other than you. For me though, I own this game, so I'm going to set the creator for me. However, I just want to make sure that you have the creator set correctly, because that can lead to other issues. Let's click on submit and copy this animation ID, click on close, and then we can close off our animation editor for now. Now, clicking on our rig, let's open them up, and inside of our pathfinding script, let's click on the plus icon and add in a folder, and let's name this folder animations. After that, let's insert an animation into our folder, and let's call it walk. I'm going to paste my animation ID inside of this animation, and there we go. Now we're also going to need another animation for attack. So I'm going to copy this, paste it, and click on attack. Now let's go back to our animation editor and make an attack animation for when he's going to attack the player. Alrighty, so I've got this very basic attacking animation right here. It's pretty simple. He just reaches up and kind of slashes his arm across. I thought it looks pretty cool actually, so I'm just going to be using this. So I'm going to click on the three dots over here, set the animation priority to action, and then click on the three dots again and click on publish to Roblox. Once again, the same rules apply with the creator. I'm just going to name this horror monster attack animation and click on submit. After that, let's click on copy ID right here, this little button, click on close, click on our attack animation, and then paste our animation ID right there. Next, we can close off the animation editor because we no longer need that. And let's open up our pathfinding script again. Now let's scroll up right up here, all the way up to the top. Let's get our animation folder. We're going to say local animations will be equal to script.animations. And then down here inside of our attack function, right before we set the player's character's humanoid.health to 0, we are going to say local attack animation will be equal to rig.humanoid.animator load animation animations.attack, and then we'll say attack animation play. So this is going to play our attack animation. Let's go down here to patrol. We're going to say local walk animation will be equal to rig.humanoid.animator load animation animations.walk, and then we'll say walk animation play. Let's go ahead, click on play and test it out to make sure it works. You can see he's got his little run animation that he's doing over there. Let's go ahead and test out the attack animation. So it looks like there is a little bit of an issue with him with the animation not looping correctly, but we're going to need to fix that. Let's test out the attack animation. So you can see that we will need to change the respawn time, but we'll do that later when we get into the loading screens and everything. You'll notice that he attacks us and then he will run away, which is pretty cool. Now, the reason why the animation is loading weird like that inside of our walk animation is simply because we're calling this patrol function every 0.3 seconds. And the problem with that is that our animation editor right here, if we were to go back and load our walking animation, you can see that this is 1 second long. So our option is to either make this a little bit faster, which may make our animation look a little weird as you can see, or we can simply move this up from 0.3 seconds to 1 second and see if this works a little better. I'm going to close off the animation editor as well. You can see the animation does seem to be working a lot better. Oh, and he's killing me again. Alrighty guys, so anyways, if you guys enjoyed this tutorial just as much as I did, please make sure you like, subscribe, and comment down below. I hope you have an absolutely amazing day, and I'll see you in the next video. Goodbye.